Hi guys, we are going to do another video lesson today, and we are on 7.3 for our topic. And the big essential question for our notes is, how can angles and sides help me classify triangles? So how can angles and sides help me classify triangles? Take a moment to set up your notes, and when you're ready, we're going to kind of dive into this essential question. Don't forget to write today's date in your notes. That's always important. We want to talk about how can we name triangles. I mean, we've learned about triangles since kindergarten. I probably, when you were 5 years old, could have walked up to you and said, "Hey, what's a triangle?" And you would have said, "Oh, 3 sides." You could have drawn me a picture. But there's different types of triangles and there's different ways of naming them. So that's what today is going to be about, is what are those different ways? And we're going to look at it through angles and sides. So there's going to be a couple different strategies. So in our notes, we're going to be building a couple of charts. Why don't we start with angles first? So at the top up here, I'm going to write angles. And let's talk about the different types of triangles that we can have just based on their angles. The first one, which I'm going to use this left-hand side to kind of write, I think, today. The first one we're going to talk about is what we call an acute triangle. Acute triangle. We know what an acute angle is. We've learned about acute angles in earlier videos. We know that acute angles are small. Remember, the way you remember it in your head is, oh, they're so small and cute. But they're less than 90 degrees. So an acute triangle is when you have a triangle that looks something probably like this. Let's just kind of sketch our best guess. It's maybe something like that. But what makes this an acute triangle is if I went in and I measured the angles. Now the angles would be these corners right here. That's the angle. It's acute. It's less than 90 degrees. Less than 90 degrees. If I had a protractor to measure it, maybe it's 80 degrees or 70 degrees or 73 degrees, but it's less than 90. It's small. And so is this one right here, and so is this one right here. All the angles, all 3 angles are less than 90 degrees. They're all acute. So the key feature in an acute triangle is all 3 angles are acute. So I'm going to write that over here. All acute angles. Okay, well that's one type of triangle. Let's look at another type of triangle. Let's talk about an obtuse triangle. Obtuse triangle. Now we know what an obtuse angle is. Obtuse is oversized, it's big, it's greater than 90 degrees. In a triangle, you can't have all your angles obtuse. It's actually literally impossible to draw 3 large angles and connect them together. You should try. It's actually a good challenge to give it a shot. But you can have one obtuse angle. So an obtuse angle would be something big if I measured it. Maybe something like this. That's a pretty big angle right there. And all I would have to do is connect this into a triangle. Something like this. This is an obtuse triangle. What makes it obtuse is this one singular angle that's in this corner is greater than 90 degrees. Greater than 90 degrees. Now these other 2 angles are small. They're acute still, but this one's obtuse, and all it takes is one obtuse angle to make it an obtuse triangle. So I'm going to write that here, that there's one, I'll change my color here, one obtuse angle. One obtuse angle. All right, so we have acute triangles, we have obtuse triangles, we also have my favorite, which is the right triangle. So that'll be the next one that I'm going to put right here, right triangle. I bet you can guess what a right triangle looks like. A right triangle is a triangle that has a right angle. So a right angle is perfectly 90 degrees. It would be something like this. Straight up and down vertical, straight horizontal. Makes this kind of triangle with that perfect 90-degree corner. If it's exactly 90 degrees, you got a right triangle, and it only takes one of them. So I'm going to draw a little arrow and say 90 degrees exactly. That's what we call a right angle. One right angle makes it a right triangle, and that's all it takes. So I'm going to write that down here. We have one right angle. Okay, so these are our options: acute, obtuse, and right. The angles that we've already learned about, but now we're using them to name triangles. But there is one more special angle triangle that we haven't talked about yet, and that is my last one for my list here. It's called the equilateral triangle. Or equal angular triangle, excuse me. Let's write that down. E-Q-U-I, angular, A-N-G-U-L-A-R, equal angular triangle. Say that 3 times fast. It's kind of hard, actually. What do you think an equiangular triangle would look like? Any guesses? I think it's going to have equal angles, right? So it's a perfectly equal angle triangle, something probably like this. Let's imagine. But what would happen is we'd go measure the angles in these 3 corners, in this 1, 2, 3, and they'd all measure the exact same measurement. They'd be perfectly equal. So we say 3 equal angles. Do you know what word we use for equal in geometry? When you get into a high school geometry class, we wouldn't say 3 equal angles. You know what word we would use? We'd say 3, I'll put it in parentheses here, congruent. Have you heard that word before? Congruent angles. In geometry, congruent means they're the same when you measure them. So if I say I have 3 congruent angles, I know they measure exactly the same measurement. But that kind of wraps up this first part of our chart here. So check it out. We have 4 different triangles. You either have the acute triangle with all acute angles, you have the obtuse triangle with all obtuse angles, or you have the one obtuse angle, or you have the right triangle with 1 right angle, or you have the equal angular triangle with all equal angles. So that's our 4 different angle ones. Now let's talk about another way we can classify. So angles is great, but maybe we don't want to look at the angles. Maybe we want to look at using the sides. So I'm going to write sides. Now I ran out of space, so I need more room. So I'm going to make my Cornell note side over here. There we go. Let's talk about the sides of a triangle. We can name a triangle based on its sides. So how can we name it? Well, first we could say all 3 sides of the triangle are not equal. How would we say that they are not equal in geometry? We'd say no congruency. So no congruent sides. We just talked about this. Congruent means equal. So all 3 sides, if you measured them, they'd all have to be a little bit different lengths. So they're not perfectly matching. These 3 sides, all different lengths. So let's write that. I'll draw a little arrow here and say something like this maybe. All 3 sides are different lengths. You get a ruler and you measure them, they don't measure the same. All 3 sides are different lengths. So we call that a no congruent side triangle. There's just nothing equal about it. So that's one option, and we have a special name for it. If there's no congruent sides, guess what we get to call this triangle? We get to call it a word that's kind of cool. It's called scalene. Scalene. It's got an interesting spelling to it. So a scalene triangle has no congruent sides. You measure it and none of them are equal. So sometimes we talk about scalene triangles because we want to name them based on their sides. The other type of triangle we can have has a cool name too. I love these names. This one is isosceles. Isosceles. Isn't that a cool name? An isosceles triangle has, guess how many equal sides? 2. 2 equal sides. So 2 congruent sides. 2 congruent sides. So scalene has no equal sides, no congruency, but an isosceles would have 2. So here's an example of an isosceles triangle, maybe something like this. Which two sides are equal to each other here? Let's mark them. This side and this side. They're equal in length. If I measured them with my ruler, imagining I drew it all to scale, they would have equal lengths. So this side and this side have equal lengths. And that makes that really cool name isosceles, the isosceles triangle. I always think of eye like my eyes. So I have two eyes, so two equal sides, isosceles. That's just kind of how I have it stuck in my head. And if it's not a scalene, and if it's not an isosceles, then it's our third category. And our third category is called an equilateral. Equilateral triangle. An equilateral triangle. What do you think an equilateral triangle is? I'm guessing you're getting this. An equilateral triangle has three congruent sides. All sides are equal. Three congruent sides. Meaning all equal sides. So an easy example would be to draw something like this. Let's imagine if I measured that with my ruler, all three sides of my triangle were exactly the same. Boom, boom, boom. Three equal sides makes it an equilateral triangle. So for my notes, I'm going to draw a little arrow here. And I'm going to write three equal sides. So now you probably know way more than you ever thought you were going to know about triangles, but now you really know how to name them. So when you look at a triangle, you can make a decision. You can say, okay, is it scalene? Is it isosceles? Or is it equilateral? And then you can, on top of that, say, okay, is it acute? Is it obtuse? Is it right? Or is it equal angular? I mean, you can really go through and give it some good names. And we're not going to do too many examples. I really wanted this video to be about making our chart, but maybe 2 examples is kind of nice to have just before we wrap up our notes today. So I'm going to write example 1, and I'm going to put it right here, and I'm going to write example 2. And I'm not using a ruler, and I'm not using a protractor, so I'm not drawing things to scale. I'm just going to freehand draw and put some labels on here to kind of practice. So imagine I told you I had a triangle that looked like this. Draw a triangle in your notes that looks like that. And I'm going to give you some measurements. I'm going to tell you that it's 4 centimeters. So let's get that on there, 4 centimeters. And I'm also going to tell you that this is 4 centimeters. I'm also going to tell you that this one's about 5.6 centimeters. About, it's not exact, but it doesn't match the other 2. And this is all I know about this triangle. Now I don't have anything to solve or do. There's no solving for x. There's nothing to do, but I can name it. What do I know? Let's start with what do I know about the angles. What kind of angle does this triangle have? A right angle. So we know this is a right triangle. So we definitely know it's right. What about its sides? Well, it's got a 4 centimeter and a 4 centimeter. That's 2 equal sides that we know of for sure. So if we have 2 equal sides, remember what we call that? Isosceles. So this is a right isosceles triangle. And there's our name for it. So we named it by its angle, its right, and its sides, isosceles. So it's a right isosceles triangle. And there we go, we got it named. Let's try another one. Let's do one more here. This time we're going to draw one that looks kind of like this. Something like that. And I'm going to tell you some information here. I'm going to tell you that each of these sides is 8 centimeters, 7 centimeters, 6 centimeters. Oops, centimeters. I'm also going to tell you my angles here. I'm going to tell you that this is 70 degrees, 70 degrees, and up here in this corner it's 40 degrees. So somebody's gone in and measured this with a protractor, given us some numbers, and measured it with their ruler. How are we going to name this triangle? So start with the angles first. Look at your chart. What do we know? Do we have all acute angles? Do we have an obtuse angle, a right angle, or are we talking equal angular? What are we dealing with here? Well, 70 is less than 90, 70 is less than 90. Those are small, they're acute, and 40 is definitely small. So we're looking at all acute angles. So this looks like an acute triangle. Acute. What about the sides? What are we dealing with in the sides? We have three options if you look at your chart. Could be scalene with no equal sides, isosceles with the two equal sides, or it's equilateral, all equal sides. What do we got? Well, 6, 7, 8. I think we have no equal sides, no congruency. So this is scalene. It's an acute scalene triangle. And we've named it. Awesome. So we'll practice this in class, but definitely this is kind of a good review, just how to name triangles. There's two ways. You can look at the sides and you can look at the angles. And if you put them both together, then you're really well naming your triangle. Definitely taking it to the next level. So thanks for watching, you guys. I will see you in the next triangle video, and have a good day. Bye.